Okay, so I want to do one last example of surface area here, and we're going to find the surface area of a sphere of radius r. Some of you might know the formula for that. Capital R is our radius. That's a fixed quantity, so whatever that radius is, that's not a variable, it's a fixed quantity for a given sphere of radius r. What is the surface area? So again, I'm going to find this by what we did up here, where we're going to rotate the graph of f of x equals the square root of r squared minus x squared, right? That comes from the fact that I'm going to put a circle of radius capital R centered at the origin, right? There's the equation of that. So if I solve for y, subtract x squared, take the square root. Now the positive root gives me the top half of that circle. If I did negative the square root of r squared minus x squared, that would be the bottom half. So I look at the top half here, but I just need the top half. So there's the function. And of course it's going from negative r to r, all right? And I'm going to rotate this about this x-axis. And if I rotate this curve, what am I going to get? I'm going to get a sphere, right? You can see that. I'm going to rotate this around. I'm going to get a sphere. And this will give me the outside area, right? The exposed area of that sphere. How much do I need to paint this sphere, to paint this ball, if you will? And so this curve right here, right, is the curve y equal to the square root of r squared minus x squared, which I'm going to write as r squared minus x squared to the 1/2 power, because I'm going to need to find y prime, right? That's the f prime of x in this, so y equal f of x in this case. So let's find y prime. Remember, capital R is a constant, but I do have a chain rule here. I've got u to the 1/2 power. That's the outer function. So the derivative of u to the 1/2 is 1/2 u to the what? Subtract 1 from 1/2, negative 1/2. And what is u? U is capital R squared minus x squared. But then I need to multiply it by the derivative of the inner function. So what is the derivative of r squared minus x squared? R is a constant, remember. So r squared is a constant. So the derivative of any constant is 0. Derivative of negative x squared is what? Negative 2x. Okay. And so if I clean this up a little bit, which I will, the 1/2 times negative 2 is negative 1. I've got negative x, and then all this to the negative 1/2, I'll put that at the bottom. So I'm going to have negative x divided by r squared minus x squared to the positive 1/2, or square root if you want to write it back in terms of that. So this is r squared minus x squared to the 1/2 power in the bottom. So there's y prime. And then I need to find y prime squared, right? That's what I need in this surface area integral. If I square negative x, I get positive x squared. And if I square the bottom, hey, that's pretty easy. Squaring the square root just gives me r squared minus x squared. Okay. So now we're ready to do our surface area integral. So it's 2 pi, and let's just set it up exactly. 2 pi. What am I going from a to b? From negative r to r. And it's the function itself, f of x. Remember, the function was the square root of r squared minus x squared. And then times the square root of 1 plus this stuff squared. Times the square root of 1 plus this stuff squared. Y prime squared we figured out already. Y prime squared is that. Okay, so now I need to find this antiderivative. You might be thinking, oh my gosh, what a mess this is. I want to do a couple of things, so in the same step. First of all, I'm going to distribute, if you will, since these are both to the 1/2 power. This is to the 1/2 power. This is all to the 1/2 power. I can combine this as 1. So in other words, if I have a to the 1/2 power times b to the 1/2 power, which is square root of a, where a is this whole thing, square root of b, where b is everything under this radical, then this is a times b to the 1/2 power. So I'm going to distribute this essentially inside that because they're both to the same power. I can do that. And I'm also going to do something else in this step, and that is by symmetry, if I go from negative r to r, right, and rotate around, I'll get the surface area. Well, what if I just go from 0 to r and rotate just this portion? I get a hemisphere, right, hemisphere, and the surface area will be half the sphere. So I can go from 0 to r and double it. So by symmetry, there's two m's in symmetry, aren't there? What I'm going to do is I'm going to say this is equal to 2 pi. I'm going to change this to 2 times the integral from 0 to r. All right, so that's going to give me from 0 to r, it'll give me the surface area of half the sphere, and then I just double it by symmetry. I'll have the total area. And then when I do this through here, r squared minus x squared times 1 is just r squared minus x squared. Okay. So again, this is the square root, right? I mean, another way of thinking about the square root of a times square root of b. This is probably how I should have written it. Is the square root of a times b. So I'm bringing the r squared minus x squared inside here, and then I'm distributing it through. What happens when I multiply r squared minus x squared times this? Well, the r squared minus x squared down here cancels with that, and I just have plus x squared. Ooh, do you see where this is going? It's looking nice now. 2 pi times 2 out here is 4 pi. Integral from 0 to r. What do I have here? Negative x squared plus x squared. This is just going to be r squared, all right, after I simplify. Negative x squared plus x, this is going to be r squared. What's the square root of r squared? That's just r. Look at that. That was a great simplification. So I had to do a little algebra here to simplify, and then I get to this. Remember, r is just a constant, so technically I can pull that r out. 4 pi r, integral from 0 to r of just dx. Well, what in the world is this integral? It's been so long since we've seen it. Integral of 1 is going to be just x, right? And we're going to evaluate x equal r, right? So this is x equal r, x equals 0. X is the variable here. So at r, I get r times r, I get 4 pi r times I is r times r is r squared. Plug in x is 0, it's just 0 minus 0. There it is. That is the formula for the surface area of a sphere of radius r. It's 4 pi r squared. Pretty cool. Again, using this idea of surface area of a solid of revolution, we are able to derive the surface area of a sphere of radius r.